Assalamualaikum. Hi everyone. In this video, I will explain subtopic 4.4 and subtopic 4.5. So 4.4, we will learn about intermolecular forces, which is also known as IMF. So first, let's recap what is IMF. So in this HCl molecule, there is a strong covalent bond between H and Cl. So this covalent bond is also known as intramolecular attraction. But between the HCl molecules, there is a weak attraction in the molecules. So this attraction is also known as intermolecular attraction, which is also known as intermolecular force. So the boiling point of a substance depends on the strength of IMF. So the stronger the IMF, the higher the boiling point. There are three types of IMF. The first one is London forces. Then we have dipole forces. And the last one is hydrogen bond. So London forces and dipole forces are the two types of van der Waals forces. First, let's look at London forces. So London forces exist in all molecules, polar and nonpolar. So previously you have learned how to determine the polarity of a molecule. So from there, we know that nonpolar molecule will possess London forces. So let's look at this hydrogen molecule. So in this hydrogen molecule, this is a nonpolar molecule where both atoms attract electrons evenly, sama kuat lah. So the electron in this molecule will be distributed evenly, but at one point, suddenly, tiba-tiba dah benda ni berlaku secara semula jadi, the electron density of this molecule is slightly higher on one side and the other side will become slightly lower. So the part where the electron is slightly higher, this is known as the partially negative part, and this is the partially positive part of this molecule. Tapi benda ni berlaku secara temporary, bersifat sementara lah. So the partially negative part of this molecule will induce the next hydrogen molecule yang pada asalnya elektron dia distributed secara evenly. Okay, so bahagian ni akan jadi partially positive part and this one is the partially negative part of this molecule. So between the partially negative and the partially positive part of these two molecules akan ada IMF. So this IMF is known as London forces. Tapi this IMF is temporary, bersifat sementara. Sebabnya the distribution of electrons in this molecule pun bersifat sementara. And at one point, tiba-tiba bahagian ni pula akan jadi partially positive part and this part will become the partially negative part. So at that point, IMF ni akan terputus sekejap sementara menunggu IMF baru terbentuk. Itu yang menyebabkan London force is the weakest IMF. Next, let's look at dipole forces. So you have learned how to determine the polarity of a molecule. So polar molecule will have dipole forces. So now let's look at the molecule of HCl. So between these two molecules, there will be a attraction. So since Cl is more electronegative than hydrogen, so this is the partially negative part and this is the partially positive part of this molecule. And this partially negative and partially positive part is permanent. Memang takkan berubah lah. Okay, so this partially negative part will attract the partially positive part of the next HCl molecule. So ini akan menghasilkan tarikan. And this attraction is known as dipole forces, which is higher, which is stronger than the London forces. Sebab IMF ni pun bersifat permanent disebabkan oleh the partially positive and the partially negative part, which is also permanent. So itu yang menyebabkan dipole forces is stronger than the London forces. Now let's look at hydrogen bond. So hydrogen bond ni hanya akan terhasil if H is bonded to F, O atau N sahaja. So now let's look at this example, a molecule of HF. So since H is attached to F, so this H can form a hydrogen bond with F from the other molecule. So the same goes to this hydrogen here. So between this hydrogen and the fluorine atom from the other molecule akan menghasilkan hydrogen bond lah, which is stronger than the dipole-dipole and London forces. But keep in mind that hydrogen bond is only formed when H is attached to F, O atau N sahaja. So now let's look at the other example. So as we can see in this example, since this hydrogen is attached to oxygen, so this hydrogen can form hydrogen bond with this oxygen. So the same goes to here. This hydrogen is attached to this nitrogen atom. So H here can form a hydrogen bond with the next nitrogen atom. So the same goes to this one here, this hydrogen here, and this other hydrogen here. So the hydrogen bond is formed between the hydrogen atom of a molecule to the other electronegative atom of the other molecule. Now let's look at this example, a molecule of CH4. So a molecule of CH4, can it form hydrogen bond with another CH4 molecule? So since CH4 cannot form hydrogen bond because H is attached to C, therefore this is not a hydrogen bond. So what type of IMF is formed between these two molecules? So first we have to classify this molecule into polar or non-polar. So from we know that this is non-polar molecule. So you have to refresh your knowledge on polarity of a molecule. So for non-polar molecule, it only has London forces. Now let's look at PF3. So this is the Lewis structure of PF3. From the structure of PF3, so we know that this is polar molecule. So polar molecule has dipole-dipole and London forces. Now let's look at hydrogen bond in organic compound. So this hydrogen is attached to O, so this hydrogen can form hydrogen bond with oxygen atom. So the same goes to here. This hydrogen is attached to O, so it can form a hydrogen bond with oxygen atom. But for these three hydrogens, since they are attached to carbon atom, therefore it cannot form a hydrogen bond. Now let's look at the comparison of the three intermolecular forces. So London forces is the weakest IMF. It is instantaneous or temporary and it exists in all molecules. But for dipole-dipole, it is stronger than London forces. It is permanent and only exists in polar molecules. But for a hydrogen bond, it is stronger than dipole-dipole and London forces, and it only exists when hydrogen is attached to oxygen, fluorine, and nitrogen atom. In terms of the strength, London forces is the weakest, followed by dipole-dipole forces, and the strongest is hydrogen bond. So as we can see here, hydrogen H2O, HFN, and H3 has slightly higher boiling point due to the formation of hydrogen bond. But CH4 has the lowest boiling point because it only has weak London forces. But here, H2O and H2S, sulfur is in lower period than oxygen, but it only forms dipole-dipole forces, and that is why it has lower boiling point compared to H2O, but higher boiling point compared to CH4. So between H2O and H2S, which one has higher boiling point? So the answer here is H2O has higher boiling point because it has strong hydrogen bond. Now let's continue with metallic bond. So metallic bond is the attraction between the negatively charged nucleus to the positively charged metal ions. So now let's look at a metallic structure. So metallic structure is imaged as an array of positive ions immersed in sea of delocalized valence electrons, which is also known as electron sea model. So it is known as electron sea model because we imagine that the electrons are moving around in structure. So metallic bond is the electrostatic force between the positively charged metal ions and the sea of delocalized electron. Delocalized electron meaning that the electron can move around. So the delocalized electron makes the makes metal can conduct electricity and also heat because electrons can move around. So the metallic structure audion here. So since A plus has one electron, so if you draw 9 in A plus, therefore you should have 9 electrons. To draw electron-C model of magnesium, if you draw 9 Mg2 plus, therefore the number of electrons must be 9 times 2 electron, which is 18. And the metallic structure electron-C model of Al3 plus, if you draw 9 Al3 plus, therefore number of electrons for this one here is 9 times 3, which is 27 electrons. The strength of metallic bond depends on the number of valence electrons and size of positively charged metal ions. So elements in the same period, you have to compare in terms of the valence electron. But elements in the same group, you have to compare in terms of the size. So the higher the number of valence electron, the stronger the metallic bond. Therefore, the higher the boiling point. But for element in the same group, the smaller the size, the stronger the metallic bond and the higher the metallic bond. Now let's identify element with higher boiling point. So for question A, between Na and Mg, these are elements from the same period. So Mg has higher number of valence electrons. Therefore, Mg has higher boiling point. But question B, sodium and potassium are elements from the same group. So potassium is in lower period than sodium, so sodium has smaller size. Therefore, sodium has higher boiling point. Now let's recap between NH3 and F3 and F3. So this is the structure of NH3. Well, this is the structure of NF3. So which one has higher boiling point? So as we can see here, H is attached to N, therefore NH3 can form strong hydrogen bond. But for NF3, this cannot form a hydrogen bond, therefore it only has weak van der Waals force, or the better part, they are the dipole-dipole forces. So NH3 has higher boiling point. Next, between calcium and gallium are elements in period 4. So calcium has 2 valence electrons and gallium has 3 valence electrons. So which one has higher boiling point? So gallium has higher number of valence electrons. Therefore, it has stronger metallic bond. Therefore, it has higher boiling point. But between calcium and magnesium, these are elements in the same group. Okay, group 2. But calcium is in period 4, but magnesium is in period 3. So for this question here, compare in terms of the size. So magnesium has smaller size. Okay, magnesium has smaller size. Therefore, magnesium has stronger metallic bond. and it also has higher boiling point. That's all for 4.4 and 4.5. Hopefully it helps you to understand better on intermolecular force and metallic bond. Thank you for your attention. Bye.